Okay, my name's David, and I'm from One Flue UK, and this is the One Flue UK building down in Southam. And today I'm going to give you a bit of an insight into the One Flue range of what we call amplifiers and controllers. Amplifiers are very simple things. They're going. Okay. So amplifiers do what they say. They just take like a command signal. So it could be a 4 to 20 milliamp or a 0 to 10 volts, and they do some conditioning to it and then send it out to your proportional solenoids. And the amplifier will send out what's called a PWM, pulse width modulated signal. This is to actually vibrate the proportional valve. So most proportional valves are vibrated to overcome the stiction. So this is what hydraulic amplifiers look like. Nothing fantastic. So they're just basically, we can have them mounted on the solenoid on the valve. We can have them freestanding, DIN rail mounted, bolted to some steel, more complicated ones on the valves. The freestanding ones we can use to control virtually anybody's proportional valve. I've been with One Flue, nearly 20 years, and I have not come across a valve, proportional valve, that I can't control with this range. Until tomorrow, when somebody comes up with one. Closed loop controllers, as they say, we call them controllers, they're for closed loop control. So all this does is take a command signal coming into the electronics and compares it with a feedback signal from an actuator, for this example, and matches the two, and it will decide whether it takes whatever it sends to the various coils on the valve. You've also got, obviously, you can use pressure control, flow control, but it has a feedback. So if a transducer, you have a flow meter, that goes back into the electronics, and that decides then what to do, so it matches the feedback to the command signal. Controllers look remarkably like amplifiers. They're all in the similar sort of enclosures, but they do have the ability to put a feedback into them. All the One Flue electronics are based on, except for one, but that's an analog one, but the digital ones are all based on Parso. This is a picture of the basic Parso software. You can download this from the One Flue website anytime you like. It's free of charge. So all this is doing is taking your command signal, putting it through conditioning, and sending it out to your solenoids. And a controller does the same thing, takes your command signal, but it compares it with your feedback signal and then decides what to do about it to send it out to your various solenoids. Generally speaking, when you're using the controllers and the amplifiers, you will need a laptop to go into it, except for these ones here. So this is what we call a PD3. This is this little animal here. And you use your mobile phone for that one. So you download the One Flue app, which I guess all you guys have done. Yeah? You all got the One Flue app? You've looked at it this morning? Yeah? Before you get out of bed? Good, I'm glad to hear it. You basically can connect up. This is probably the latest one we've got. So this allows you to have a look what's happening in the amplifier, and also you can change settings with the phone. The PD2 is a nice one. It just gives you a little bit of a display, so you can see what is happening with the amplifier, what signals going into it, what signals coming out. And they have with the PO2, the guys that like it, so this is a PO2, and this uses a screwdriver to basically change the settings. If you've got any questions while we're going along, just ask them as we're going along. So when you're looking at controlling a proportional valve, when you look at the proportional valve's data sheet, there are certain things which you need to know or need to look at. First thing is what is the maximum current going to your proportional valve. We look at what we call I mins and I max. So the maximum current that we can send to this proportional valve is 930 milliamps. Proportional valves also have quite a large deadband if you're using like a directional control valve, like a 4-3 spool valve. So you have to move the spool so far before any flow is going to come out. So we have what's called a deadband, and we're overcoming that with the I-min setting within the par zone. If you've got like a pressure control, a pressure reducer, pressure relief valve, proportional, then there isn't such a deadband. There's very little deadband. But for directional control valves, spool valves, you have deadband. So you need to know a little bit about this before you go forward to program things. Hopefully by the end of there we'll be able to go on to what we call our MD2, which is this one here. And this controls up to 8 solenoids at the same time. And so it's quite capable of interlinking a simple circuit together. So you've got a dump valve, proportional reducing valve, directional proportional directional control valve. And it's to link all those together. So what we're going to do is hopefully hook up to an amplifier. Amazing. So this is what Parzo looks in reality. So we're connected up to a basic amplifier, what we call an SD7. So we're taking the command signal, we're putting it through ramp generators and out to the side. And when you're looking at this and you're setting it up, the first thing you need to know is what type of valve do you have. So we're going to use this one. So this is a 4-3 spool valve. We're going to control the hydraulic cylinder. And we're going to use a single input joystick. The mid position of the joystick is 5 volts. So it's a 0 to 10 volt joystick, 5 volts being the mid position. Fairly common. You can use bipolar. So if you have a 0 to 10 volts positive and a 0 to 10 volt minus, you can use it, or you can use the same input with a digital switch. Okay with that, guys? Yeah? Good. We have a ramp generator, so you can put in ramps, so you can obviously soften the way things move around, ramp it up, ramp it down. When you're using a joystick, if a man's using a joystick, this can be quite difficult, because if you put a ramp in, if he moves his joystick and nothing happens, he's going to move his joystick more, then the ramp kicks in and you're a bit all over the place. So, but if you're coming from a PLC or you're ramping up pressure, not just a directional control valve, then ramps are very useful at the moment. So for this example, we're off, we're not using them. You can also put fixed values in here, so you can fix the value of speed to go out with the cylinder, to move the cylinder at a certain speed, or if you've got pressure, you can fix a certain pressure, so you can use digital inputs to set 2 or 3 pressures if you want a fixed set pressure. Signal scaling, well, it is what it says. This is, you're choosing which to do, so we can choose voltage, current, or a digital input in this case. And when we choose the analog input we use, we're not going to use cable break because we're using a 0 to 10 volt signal. 0 volts is a good signal, so we don't use it on this occasion. And you scale what you've got here. So maximum voltage, 100%, minimum voltage, minus 100% to go to the B solenoid. As you can see from there, we haven't got 0 to 10 volts. And the reason for that is, on the demo kit, if we turn it up to the top, here's the voltage here. We don't have 10 volts. It's very rare you will have 10 volts. You'll lose something along the way. So you will scale what you have there and go into the minimum, 0.01, and you can put that in there. Now I've actually scaled that, as you can see. So I've put my 0.01 in and my 9.87, so I get minus 100% plus 100%. Solenoids, so now we set up the solenoids. You can have them enabled or disabled, but have to have a digital input to enable them. If you want some safety, you can invert them. You can have a cable break on there. We have a characteristic curve. So we can change the characteristics of the valve. We don't have to have 50% signal equals 50% out. We can make it more sensitive for more of the movement of the joystick, or less sensitive then when we get higher, so we can actually move things quicker if we need to. So we're going to have, for this application, it's off. So we set the Imax, which we had on the previous slide, to 930 milliamps. We need to set up the I minimum. Now the I minimum default is about 150, but you have to look at the actuator. So if it's moving a cylinder, you have to be looking at the actuator and increase or move the input signal to the coil. You don't need anybody to do that here. You can do it using the software. So you can take it over and you can increase. So if you look at just over here, so what you're doing is you're increasing or decreasing the milliamps to the coil in steps. When you see the actuator move, you've overcome the deadband. So decide how much you've overcome it and put in the value, so that when you actuate this solenoid, it'll jump over that deadband and then start to work. So you're not having to move your joystick, and then it works. It'll move instantly from your joystick. And you can do the same for the other side as well, for the B solenoid. As you can see there, well, we've shot up to the maximum amount. Lack of control of the mouse. And come out of that. So you then put the I minimum for both. The I minimum will not be the same for the A and B solenoid. No two, well, I've not found it yet anyway, that they're exactly the same both ways. Everybody okay with that? Bashing along at quite a pace, right? We also have a dither, the superimposed dither. We give 1,000 hertz pulse width modulator signal out to the valve as standard, and then we can superimpose a dither. If you have lazy solenoids, you basically have a low hertz, high amplitude, therefore you'll give the valve a bit more of a shaking, make it work, and vice versa. And in some systems, you need to be able to play about with it. Nine out of 10, that's it. We're off, we're working. And then you'll get some people ring up and they've got this problem, that problem. So one of the things you're going to get is, oh, it's not very stable. You know, it's the cylinder oscillating around, messing about. So you will come on and you'll go into Parzo and you may check the voltage and you might see it just flickering a little bit. But the way it is, it's not that sensitive, so you can't see it very much. That should be disabled. So when you're doing, you might, it's sort of 0 to 3 volts, you can see it going out to the milliamps going out to the coil, and you might see that flickering a little bit. So you think, well, okay, we're moving or oscillating the valve. The command signal coming in is oscillating. That's what's giving us the problem. So you call their electrician over and say, okay, what's going on? You know, I'm moving around. And your electrician will come on with his multimeter and stick it on the thing, and he'll be dead smooth to 2 decimal places because his meter has got lots of filters in it. And so he's going to away, say it's your stuff, it's your hydraulics, it's, you know, get on with it. So what we have is we have an oscilloscope, and we can set up what we want to look at the oscilloscope, so we can look at the command input value. And with all oscilloscopes, you need a trigger point. We're going to take a reading 0.004 of a second, so we're going to see noise coming in from the command signal. So, right, start. So I've got to get past my trigger. And you'll be able to see, I mean, that you can't see it very well because it's so quick. But that brings in, you can see here that the green is your solenoid, and you probably see that doing this because it's unstable. And you can see blue is the command signal, and you'll see that oscillating around. So you know that your command signal is oscillating. Depending how bad it is what we can do about it. I have been on site, and I have had a command signal wire coming past a big AC motor, and yes, the command signal is very unstable because it's not, it just picks up. So yeah, everything is unstable. We've got a couple of things we can do. You can ask them to do a better wiring job. Good luck with that. Or we can put a filter on. So effectively we've got a range of filters. Obviously 64 is higher than the one, so we can actually take out noise. So if it's got a bit of noise on it, we can deal with it using the SD7.
What's the downfall?
Sorry?
What is the downfall of putting that on?
It's not quite as sensitive.
Yeah.
But in an amplifier using a joystick, it's not that sensitive. You know, you're not going to see it. But it is, yes, it does take a little bit of the sensitivity out of it, but it will calm the system down to a point. I mean, this guy with his wire, which was running past his AC motor, there was not a chance. It wasn't screened, nothing. It was impossible. You can do lots of different things. You can monitor. That is the basic amplifier. There's a lot more features on it, a lot more things you can do with it. This is 2 solenoids. You can use this one card to control 2 independent single solenoids, like 2 pressure reducing valves on the system. You can just use the 1 card. You will then go into channel 2 and do the same. One other thing that we get asked for and we have used, if you're on the deck of a ship and you've got a winch, so you're bringing up whatever it is at the bottom of the sea, and you want it to come up quickly, so you want it like this, so you've got your maximum power going to your coil, and you're winding it up as quick as you can. But when it gets to the deck, you want to slow things down. Well, obviously you can do that by bringing the joystick in and using just a bit of the joystick. But what we can do is go into command scaling. Got to disable the card. And put at the bottom here, you can see an alternative. And we're going to use digital input 2 to switch to the alternative. so the alternative we're going to do is still use the same digital input. He's still on the same joystick. He wants it now more sensitive, so we're going to say, okay, for 0 volts, we're going to use half the signal, and for 10 volts, another half the signal. So he's at half speed, but he's using the full movement of the joystick. So at the moment, he's using full speed. Enable the card. So he's got 930 milliamps going out to his coil. If we put digital input 2 in, we're going to switch to the slower speed, and he's now dropped to 536 milliamps. And I know that's not 50% of 930 milliamps, but it's 50% of the difference between I minimum and I maximum, plus the I minimum. Now that feature's used quite a bit, not just on winches on ships, but quite a few people use that where they want a sensitive system or they want a fast system. You can flick between the two. You okay with that, guys?
So you have a switch on there, would you, to switch
Yeah,
across?
switch across, yeah. So fast, slow, slow,
So
fast,
switch.
yeah, yeah. There's lots of things you can do on here, so if you're in your command signal, you can always hit the help button and up comes the instruction manual to help you out. Being a bloke, I've never read it. Functions, at the moment we have, if solenoid 1 or 2 are active, we have a digital signal out. So they're active, we have a digital signal out. So you can say, well, we're moving, we're doing something. Back in the, if we disable again, signal scaling, we have what's called a dead band. So if you've got a joystick, at 5 volts in the middle is nothing. You're never going to get to that 5 volts because it's always going to be wavering about, moving about, jumping about. So you're always going to be flicking between the solenoids. So we put a dead band on the joystick. So at the moment it's on and we have a 5%. So when you get close to 5 volts, it's going to go off. So if we look on, we're on the slow speed, we're at 9.8. So if we come down to 5 volts, if you can see now we're at 5.31, but we've knocked off the coils. Right, so that's the basic amplifier. Any questions on that? We're okay with that? Yeah, all happy to use that? Good. So what I will do is connect up a controller. Right, so now let's say we're coming on site, we've plugged into our amplifier, we wish to connect. So we have activate online, we want to go and look at it, so we're connecting up to it. And it'll give you a choice. So you can either send down a program from your laptop, so if you've got quite a few SD7s of all the same programs, similar programs, you can just send it all down, or you can have a look at what's on the SD7. So we're going to have a look at what's on the SD7. So this is a controller. So basically you have the same command signal, but now you have a feedback signal. And what the valve is going to do is compare the two and operate accordingly. But once again, you've got to select what you want to do. So with a controller, you can use the controller as just an amplifier if you wanted to, that's fine. But again, we're going to go for position, closed loop, 2 solenoids. So again, we're going to use the 4-3 proportional spool valve, and we're going to control a cylinder. So we select position, closed loop, 2 solenoids. It's going to adapt it. with the valve type, you now have no choice. It knows it's going to be a 2-solenoid valve. It's going to use unipolar. It's going to sort itself out. Now the ramp generator is now a little bit different, because now you can set the maximum speeds you want the cylinder to move, the maximum ramp up. Ramps will ramp up as you travel out, ramp down, and when you come back, this is the minus, so acceleration back and forth. So you can have all different values. So this is quite slow. The speed is 10 millimeters per second. But you can set it up there how you want to do it. So if you've got a big load where you're pushing something out, you want to go slow out. When you've dumped the load the other end, you want to come back quick. So you can change those settings in there, out and in. Command fixed value, the same again. You can decide, but on this case, you're not deciding on the speed, you're setting how many millimeters you want the cylinder to go out. So on the scaling, we've now got a command signal of 0 to 9.88 volts. We've decided we want 100 millimeters of travel. So we have the reference at 0 millimeters and the maximum voltage you're going to give the command signal at 100 millimeters. With the feedback, we want to use 0 to 100 millimeters. Typically you have a 4 to 20 milliamp feedback signal from the transducer. You don't have to have a 100 millimeter stroke cylinder. So you could have a 120 millimeter stroke, whatever else you want to do. You can use that manual sliders, which I showed you earlier on the amplifier, to move the cylinder into position. And what you're looking at is when you are in position, taking a reading. So the cylinder might be stuck out 12.5 millimeters and it's a 6 milliamp signal, but that's where you want to start. That's your 0 milliamps, millimeters rather. So you can change, you can put in here your minimum interface, 0 millimeters, 6 milliamps. And then when you extend your 100 millimeters that you want to be at, you will see the milliamp again on the feedback. If you have a 100 millimeter stroke cylinder and you're going from one end to the other, when you fully retract the cylinder and you've got a 4 to 20 milliamp transducer, you aren't going to get 4 milliamps. It'll be 4 point something or 5 or something like that. So this is when you scale it in here. And when you fully extend it, you might have 18.2 milliamps. Scale it in your feedback. So then when you do your command signal, you're matching exactly where you want to go. Setting up the solenoid is pretty well the same as we did with the amplifier, except this I minimum becomes a lot more important to get it right, so that the solenoid, the valve, doesn't have to flick any dead band at all. It's straight over, straight back. So that can have quite an effect on your performance of the system. Right, so when you're doing closed loop, you can set up what's my output signal scaling. So this means this is a command signal for millimeters, output feedback, millimeters, and you want to know the power going to each of the solenoids. When you're doing closed loop, this oscilloscope is absolutely golden. It helps out big time because you can see where you are, how you're matching things up. So if we new, start. So I can see the blue line is my command signal. The red line is my feedback. So you can see it matching, and you see something like this. Enable the card, it would work. So green is a solenoid. So the solenoid has reached as much as it's going to reach in terms of milliamps out, but we've still got this, we're not there. So within, obviously, the controller, you have PID loops. So you can play about with the amount of amplifier, amplitude you get into the valve, until you get it as close as you can. It's sometimes made overshoot. We have an integrator you can use. So there's quite a lot of tools in the PID integrator to make the valve perform exactly as you want. What you're trying to do is, so we'll have a scroll this time just for the, so you can see now when we're below the feedback, we have solenoid B. When we're above it, we go solenoid A to try and bring up the feedback signal. So if the feedback signal comes up, we see the green solenoids coming down in value. And then when we get to them pretty spot on, you'll see both solenoids here I've got set so they both go off. We're in position, we go off. You can set up monitoring as well. So we can set up a signal out. So when you get within your target window, I've got 5 millimeters here, it could be 0.5 millimeter. And we can have what's a trailing window. This is just a light on the SD7 to say we're within 3 millimeters. But when we get within 1 millimeter, we'll turn the solenoids off. So the system will still work even though we're in target window. It'll still try and get closer. So these are them here. So we've reached target window, solenoid is off. If we come out, so now we are out of target window and we're out of the trailing window. Get back again. So now we are within target window, 5 millimeters, but we're not within 3 millimeters. So it's just so you don't have to keep looking at the two values and trying to work out where it's flicking about. And then when you get to within, your solenoids are off, you're in target window, you are 0.5 millimeter out. On the enhanced amplifier, I control cylinders to 0.1 or less position control. Depends on the application, depends on what you're doing, but we can get very good accuracy. One thing you need to be aware of when you're looking at digital controllers is their bit value. So a basic controller is a 10-bit, so that's 2 to the power of 10, that gives you 1,000 divisions. So if you, for example, have a 5-meter cylinder and you want to be plus or minus 1 mil, it isn't going to do it. It hasn't got enough divisions. You're only going to get plus or minus 10 millimeters with 1,000 divisions. So you go up to an enhanced controller, which has 16 bits, and that's more than enough. Any questions? Anything else like to know about a controller? No? Good? Means I'm really good at what I'm doing then. Is that what I'm right? Okay, so what we'll do now is we'll go to, we've got a little hydraulic circuit which Greg's going to give you out. So we can control a basic hydraulic circuit which you saw on the board using an MD2. So basically, if you've got a simple sort of power unit and you've got a few valves on it, a couple of proportional valves, a couple of directional valves, a dump valve, then you can use one of these, an MD2, 8 solenoids. It's IP67. The heat sinks are on the back, so just bolt it to some steel somewhere, and that's it. It'll look after everything. So if you look on the picture there, you've got on the right-hand side the dump valve with the relief valve under it. So the dump valve, when you want to do something, you need to energize the dump valve. So what we have here, we have an internal signal. So when we get an internal signal, then the dump valve will come on. We have digital inputs to control the solenoids, which is item 2, just the bang bang valve. What we do have with this, as well as all the proportional stuff, we've got, obviously now we're going to switch a solenoid on and off. Piece of cake, not a problem. If you hit digital input 1 in this case, the solenoid comes on, and after 2 seconds we reduce the power to 50%. So now the solenoid isn't going to get too hot. But if we look at channel 1, we've also energized the dump valve. Once again, we've dropped to 50%. That's the difference between being able to hold a solenoid or being able to fry an egg on it. So dropping them down to power helps a lot with the heat. But what it is, you've selected a function, your dump valves come on. We're now going to look at the proportional pressure reducing valve. And as you can see, you use an analog input. So here we have the voltage going in. For this demo unit, for some reason, it doesn't tell you what the milliamps are going out. As with the SD7s and the MD2s, the MD2 gives out a stabilized 5-volt signal, so you can take that, put it around your pot or your joystick, and send it back into the MD2. So you don't have to generate a command signal. It'll just do it through whatever pot you want to do, or a joystick. So you've energized the valve, you've got some pressure, you move the cylinder to where it wants to go, or you've got something pressed, and then you bring in, on the right-hand side there, you've got a proportional valve. Once again, we've got the dead band on it, so we're at 2.5 volts, and we can send the cylinder out, or we can send the cylinder back. So you can do that. I'm a hydraulics engineer. I can program this up. I don't need some electrical guy to come and bamboozle me with some software or whatever else. It's done. You can set it up. So you can have 8 solenoids. So actually, the 2 proportional valves, you can close loop them because you've got enough inputs and an MD2 to do it. So you basically, from this, you've got the switching of the valves, reducing the power, so you reduce the heat. You've also got the proportional valves, so this does it all. So you can have just a little panel, switching the solenoids on and off, increasing, decreasing, looking at whatever you want to do, closed looping it or looking at a pressure gauge. Any questions on that, guys? Right. Let's get back to the presentation. Right, where's my pointer? If I've whetted your appetite, you want to know a lot more about it, surprisingly, we have videos on YouTube. You can access them through the OneFlu website. So we have Adrian and Stefan. These are the guys that program. These are the guys that have done the software, and they'll talk you through how to make, you know, the closed loop control, simple amplifiers. This is the PD3. This is the one that you use your mobile phone with. They're all on YouTube. And they're very good, very simple, very good how to do it. However, when they set the program up, it works perfectly. In the field, it doesn't quite go that well. You might have to mess about a bit more. Okay? Thank you. That's me talked out. Thank you, guys.